And we are we live? We are live. Good. Okay, here we go. 12:17. So today what we're talking about is applications of parametric equations. And parametric equations are position and time. Okay? All right, so let's sketch. X of t, t squared plus 1, and y of t is 2 plus t, all right? So create values. So we're just going to plug in 0 to negative 2. Okay, so I've plugged in 0 in for t into both, right? We'll get an x value and a y value, which is a position. So at 0 seconds, I plug in 0. 0 squared is 0 plus 1 is 1. I plug in 0 here, I get 2. Okay, so we know that the particle, the ball or whatever, is at the position 1, 2 at 0 seconds. If I plug in my 1, 1 squared is 1 plus 1 is 2. If I plug my 1 in here, I get 3. If I plug in my 2, I get my 2 squared is going to be 4 plus 1 is 5, that's right, and 2 plus 2 is 4. 3 squared is 9 plus 1 is 10. And 5. Everybody good? Right? Everybody good? And then if I plug in negative 1, negative 1 squared is a positive 1, and 1 plus 1 is 2. And then if I plug in a negative 1 here, I get a 1. If I plug in a negative 2 squared is positive. 4 plus 1 is 5. And then if I plug in my negative 2 here, I get a 0. Okay? So let's just plot this. So I'm going to go ahead and I'm going to make an XY axis. Okay, how am I doing? Okay? So then I'm going to go ahead and have the position at 1, 2, and that's going to be, and I'm going to label this next to it, that's T0. Okay, I'm going to label that point's T0, so I put a little T0 there. I'm going to put the position at 2, 3. 2, 3 is here, and I'll label that as, grab a different pen, that's at T1, T0, T1. Let me put T0 back down here a little bit closer to it. T0, T1. I'm going to have the particle is at 5, 4. 1, 2, 3, 4, 5. 4. Okay, and that's at T2. I'm going to have particle at 10, 5, which might be off my page maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 barely. And then 5 is here. And that's at T3. And the reason I wanted the negative time is because I kind of want to find out where it was. Okay, that's T3. So 2, 1 is here. And that's T equals negative 1, okay? Okay, that's T negative 1. And then I've got a 5, 0. 1, 2, 3, 4, 5, 0. And that's T negative 2, okay? So, in a sense, the particle goes like this. It's moving in this direction, right? It's moving in that direction. How do I move it? How do I know it's moving that direction? Because of time, right? Negative 2. I should say negative 2. Okay, negative 2. Starts at negative 2, negative 1, 0, 1, 2, 3. Okay, we know it's moving in this position. That's what I like about parametric, is it tells us where it's at, right? Now, can we put this in the calculator? Heck yeah, we can. So to put in the calculator to graph it, what we do is this. Let's take a look at our two equations. We have x of t equals a t squared plus 1, and a y of t equals a 2 plus t. And we can put in our calculator and get this exact same graph with the calculator. So if I go to my, make sure my mode's on parametric, which it is. Go to my y of t, clear that, and let's just type in my t squared plus 1. Am I going too fast?
Yeah. Can you move your calculator?
Yeah, sorry, you guys. You want the graph? You still working on the graph? Okay. So I'm just typing these two equations, which came from the original, into my calculator, because the calculator is going to do it for me as well. So, and then y of t is 2 plus t, okay? Now before I do a whole lot of things, the last problem I did was the baseball problem, and that's not going to fit my graph at all, because we had it going out to 400, right? So we're going to change my window, okay? So Zoe, we're going to change our window, and what should we do for time? Now think about it. What should we do for time? Think about it. What should our time be?
6.
Where's our time here?
-2.
-2 to what?
-2 seconds.
3, right? So let's make our time go from -2 to 3, because that's our time on our chart. So we'll let our time go from -2 to 3. Okay, good. Scales. We actually went by scales by 1, but we can keep it to 0.1. Actually, I'll go 1 and you'll see. I think I showed you this yesterday, but we'll see it. X, if I look at my x-axis, 0 to probably 10, right? But I'll go a little bit further. I'll go 0 to 11. Sounds good. I like 0 to 11. Sounds great. Scales by 1. My y-min, 0 to, looks like about 5, but I'll go maybe -1 to maybe 7. So I'll go -1 to 7. Okay. Now, when I graph this, remember, it's like the strobe light. I'm only doing my time. Okay, it's important you guys know this. My time is by 1 second, okay? So it's going to look weird. I'm going to show you what I mean. So if I graph this, boom, graph it. It doesn't look too curvy, because what it does is it goes straight to here, straight to here, straight to here, straight to here, okay? Now if we want to make it a little more curvy,
We do 1/10.
we do 0.1 or 1/10. So if we go to our time, go back to our window, and if we change our time scale instead of 1 to 0.1, then it's going to graph the think about it as a particle moving. It's going to show the particle every 10th of a second, right? So we get better accuracy, okay? It's like the strobe light, okay? Instead of strobe light going on, you want to see here, here, here. If we go every 10th of a second, it's like da, 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 we see a better picture of it. So if I change my time scale to 0.1s and graph it, I get a better curve, right? It looks a lot more curvy because I get a better interpretation. Now, if I want to find out where it is at any particular point, I can just use my trace button. I can go trace, and I can go to 3. Boom, there it is. It tells us exactly where it is, okay? Now, let's take a look at number 2. So number 2, if I want to graph this, that's kind of hard to do. I could plug in 1, I could plug in 2, I could plug in 3, but wouldn't it be easier if we just went straight to our calculator, okay? So let's put this straight into the calculator. Now, before we do a whole lot, okay, y equals, right? Clear that, clear that. So we'll go 5 cosine t, and we'll go 3 sine t. Okay, now we're going to go to our window, and we're going to be smart. Go to my window. We're going to be smart. Okay, I've got sine and cosine. Okay, sine and cosine, which means we're going to be doing degrees or radians. It does not matter, but what matters is the window. So first of all, what mode are you guys in right now?
No.
Check it out. Well, I think we're in degrees. Aren't we in degrees? Okay. Yeah. Okay. So if I change, let me go to my mode. I think I'm in degrees, okay? Yeah, I'm in degrees. I'm going to go back to my window. So, time. T is like your time, right? T is like your time, which is your angle. So we're going degrees. So if we're going to graph a sine and cosine, we're going to go around the circle. So we're going to be smart. My time's going to go from 0 to 360. Does that make sense? My time's going to, because I want to see it go all the way around the circle. So I'm going to go from 0 to 360. Now if I'd done radians, I would have made that 0 to 2 pi. You with me? Okay. Every 10th, this would take it forever. And this is going to use up a whole lot of batteries because you're going to go all the way around the circle and graph every 10th of a degree
Oh, Dad, use it more battery?
Yeah, because it takes forever. It's gonna go. I'll show you. Watch me graph it.
We don't want your batteries to get.
Well, let me show you how slow it is. Negative. Let me do this real quickly. -5 to 5 and -5 to 5. I'll just do it. Okay, ready? Graph. Watch how slow it goes.
Where even is it?
It's coming. It's coming. Do you see it?
No. Oh my good night.
It is graphing every 1/10 of a degree.
It's a screen.
Yeah, and so it's super accurate, but what a pain. So you know what I'm doing? I'm going to push quit, stop, quit, quit, stop. It won't even quit on
Wait,
me.
it's getting bigger.
Yeah, wait, look at that.
It's going around.
Wait, what should we put ours in?
Put your scale as 1 degree, and it's going to go around the circle a lot faster.
Is it supposed to look like an elbow?
Oh, yeah.
Yes, an ellipse.
But see how it's getting bigger?
Oh, it's taken forever to go around. So I'm graphing every 1/10 of a degree. And that's why it's going
You graph
so
even smaller?
slowly.
You do like a fifth?
You can do a fifth. That'd still be slow. Why don't you just do-
0.05.
That'd be even slower.
I know, I want to see it.
No, I can't even stop it. It's like so busy working that it's just killing me. So when I do degrees,
I'll do it.
I'll go every 1 degree. I'll do it in terms of 1 degree. When I do radians, I'll do 0.1s because radians 0 to 2 pi, right? I'll do 0.1. So it's just taking forever. It's just crawling around there.
Okay, but why does it get
Look,
so
it's spread out in the middle right there.
Yeah. So it is an oval or an ellipse. It is an ellipse, okay? And then what? Take a look at this number here. 5,
Yeah.
5 and 5, okay? And this number here, 3, 3 and 3. So it's an ellipse that goes on its major axis 5 and 5 and its minor axis 3 and 3, center at 0, 0, okay? It still looks pretty flat, doesn't it? So a long time ago, kids, remember, they used to take movies, now we've talked about this, and they would format the TV to
Oh, yeah.
fit. So we have is a rectangular screen. So my oval is really pretty flat, right? And if I want to change that, I can change it to a square screen, okay? I've shown you how to do that, but I can't do anything right now
No, I can't either.
because I mean, this is just killing me. Think about all the battery I'm just killing right now, right? And I'm recording too. What a waste of recording, right? What a total waste of recording, right? So if you were to watch this film tonight, you'd be going, okay, come on, Mr. Davies.
We
Finish
can
it up.
just skip over.
I'm almost there though, right? Almost there.
You should try
Find the
doing
videos. I'm refreshing here.
What video?
Oh, they were looking at one, and then they saw one where we were singing to Cameron, "Happy Birthday to Cameron," on
What is
YouTube.
one?
I think I'm done. Am I done? Am I done? I'm done. Okay, now if I go out a window, we want to see something different. We go to window. So if I change this to
56.
1, but if I change it to 10, watch this. If I change it to 10,
66.
if I change the steps to 10, it's going to graph every 10 degrees. So it won't look as circular, but graph. Check this one, graph. Okay, it'll go a lot faster, right? See how much faster that went, right? Okay, watch this. What if I went every 90 degrees? How's it going to look if I put 90? Just real quickly. How's this going to look if I went 90? Any guess?
Oh, really? Like a...
Yeah, it's going to look exactly like that. It's going to look like kind of like a diamond. I guess it's going to go 0 to 90, 90 to 180, 180 to 270. So check it out. Okay, graph that. Okay. Which that's not really the graph, is it? So even the 10 wasn't bad. Every 10 degrees. I did get a circle and it graphed it a lot faster, okay? Okay. So this turned out to be an ellipse. Let's write that down. This turned out to be an ellipse. Oh, come on, Bill. 5, -5, 3, -3. It turned out to be an ellipse that looked like this. Now, where's the particle? At 1, 2, 3 seconds. So I'd have to go back to my window and I could do my trace, right? I could do my trace. 10, 20, 30, 40, and I can find out where it is at different spots, okay? Now, ready to turn the page? All right, here we go. Okay, it's a big football game. Okay, but instead of a baseball problem, let's change it to a football problem, okay? So, a football is kicked with an initial velocity of 45 feet per second and an angle of 50 degrees. The goal is 100 feet away and at a height of 15. If the ball is on line, meaning, if it's going to go straight, will it go through for a field goal? So, let's do this. So, my first equation is going to be x of t equals 45 cosine of 50 t. Okay? That's my horizontal. And then my vertical is my y of t is going to be 45 sine of 50 t. But we got to remember gravity minus 16t squared. Okay? Now, here's my two parametric. This is my horizontal because the ball is traveling horizontally. And it's my vertical. So together it makes the path. As the ball is moving over, it's also moving up and down. Okay? This is horizontal, this is vertical. So if we put that on our calculator, okay? So let's go ahead, y equals, clear that, right? Go down and clear that. And I'll put my 45 cosine 50 t. And I'll put in my 45 sine 50 t, subtract 16 t squared. How am I doing? Okay? Am I going too fast? Now, before I kick the ball, let's make the window fit, because the last window I had was 0 to 360 degrees, right?
Oh wait, Mr. Davis, I think it's wrong.
Oh, what did you do wrong?
You skipped. They're on opposite.
Oh, I did, Zoe. Thank you. All right, let's go 45. Thanks, Zoe. Cosine 50 t, and let's clear that. Clear that. Thanks, Zoe. That was going to mess me up, wasn't it? 45 sine 50 t, subtract 16 t squared. Okay, now let's go to my window and let's be smart, okay? Time, right? How many seconds do you think the ball is going to be in the air? What do you think? Just 5 seconds, maybe?
Sure.
Okay, we'll say 5. If it's more than 5 or less than 5, we'll figure it out, okay? Steps. Let's go by tenths of a second. Does that make sense? Tenths of a second? 0.1. Minimum 0 to how far do we want to kick it?
100.
So let's make this more than 100. Let's make it maybe 120.
101.
101. Okay, good enough. There we go. Scales by 1. Minimum 0. How high do you think we're going to kick the ball?
15.
Well, it's going to be at a 50-degree angle. I'm probably going
It
to...
says at a height of 15.
Right, that's the goalpost. That's the goalpost. I'm going to try 100 and see what happens, okay? Guys ready? Set. Okay, and I'm going to kick the ball. You ready for me to kick the ball?
Yes.
Ready, set, boom. There goes the ball. That looks like a pretty bad, weak kick, doesn't it? So, where's the goalpost? Let's go to, how do I find? The goalpost is there somewhere, but where? Where's the goalpost? Where's the goalpost? It's 100 feet away, right? But I don't see that, so, yeah, how can we find the goalpost?
How can we?
Yeah, where's the goalpost? Trace. So, we want to watch the x value. Because right now the x value is 0, right? We want the x value to become 100, right?
Yeah.
Okay, so, all right, trace. I'm going to move it over. Okay, here's the ball. Okay, it's going. We're at 40 feet. We're at 50 feet. We're at 54 feet. We're at 60 feet. We lose the game. Right? Because at 2.2 seconds, we're at 63 feet. And the times and the y value is -1. We lose. Guys agree? Goalpost is right about here somewhere. You guys agree with that?
Should have done your homework.
I know, exactly. I should have my homework. So, graph this. So, if I graph this, it looks more like this. So, about 60 feet, right? Starts here, hits about 60. If I go back and hit the top of this curve, I know at about 1 second, it's at about 30 feet. T0, T1, and about T2, okay? My goalpost is sitting right here, right? There's my goalpost, and we lose. Wow, bummer, huh? I know, we